Okay, in this video we're looking at how pressure affects the position of equilibrium. When you talk about pressure affecting position of equilibrium, you've only got to look at the reactants and products which are gases, because pressure only affects gases. So in this reaction, every reactant and every product is a gas. So the first thing to do is look at how many moles of gas you have on each side of the equation. So we've got 2 moles and 1, so 3 moles on this side, we've got 2 moles. So this side will be at a higher pressure than this side will be at a lower pressure, because 1 mole of any gas occupies 24 dm cubed. So if you've got more moles, you're going to need more volume, okay, more space for those moles to be in. So this side will be under higher pressure than this side. So if you imagine all this, a mixture of these 3 gases are in a container, okay, all in the same container. If we increase the pressure, the complete total pressure of that container, the system opposes the change, the Chatelier's principle. And it does that by moving the position of equilibrium to the side with fewer moles of gas. So there's fewer moles of gas on the right hand side here. Okay? If it moves to that side, that lowers the pressure. And in this case, that's to the right. So every time you look at these equations, look at how many moles of gas you've got on each side of the equation. And then remember that if you increase pressure, it goes to the side with fewer moles of gas. If instead we decrease the total pressure rather than increased it, the system again opposes the change, and it does this by moving the position of equilibrium to the side with more moles of gas. So there's more moles of gas there. So we've decreased the pressure, it's going to try and increase the pressure by going to this side. So in this case it's to the left. So for different reactions it could be different whether it's the left or right depending on the ratio of moles. If there were the same number of moles on both sides of the equation, so it was 3 and 3 or 2 and 2, then changing the pressure will have no effect on the position of equilibrium. Okay, what about catalysts? How do they affect the position of equilibrium? Well, a catalyst speeds up the rate of reaction, but it speeds up the rate for the forward and backward reaction. And it does so equally, so as much as it speeds up the forward reaction, it will equally speed up the backward reaction. So there's no net effect on the position of equilibrium. The rate at which you reach equilibrium will be quicker, because reactions take a while to reach equilibrium from when they initially start. So if you just start with reactants and no products, it's not reached equilibrium yet. It takes a while to get there. Okay, but if you use a catalyst, you'll get to equilibrium quicker, but it won't change where that position of equilibrium is.